Deval will help us on the lab. So this is a lab, so we expect you to follow along, do some exercises, use the software stacks that we built for media application development. So when we talk about media, we usually think about watching TV shows from YouTube or from the your TV set-top box. So this is one way of looking at the media. But recently, these few years, media is undergoing some transformations. Service providers are trying to add more dimensions to the media consumption experience. Media becomes more interactive, away from the passive media consumption experience to two-way communications. People are analyzing the media content delivered to you and figure out what's in there and tailor the content to make it more relevant to your experience. And also, needless to say that media becomes everywhere. You can consume the content as well as create content anywhere at any time. So we basically just call this new experience as a visual experience, and we are creating a visual cloud, the experience to associate with it. So let's look at in details of what are the specific services around this new experience. So on the left side, there is this media processing and delivery service. So this is the traditional media, so streaming content over the internet to your edge devices. And this is still the solid driving force behind the internet growth. So on the right side, there's the media analytics. We'll try to analyze the content, understand what is in that content that delivered to you, tailor the content or transform the content to make it more personalized and to enhance your special viewing experience. And of course, media does not have to be 2D, right? We're adding different dimensions to the media consumption. So 3D content, 360 video streamings, AR, VR content, adding all kinds of things into the mix. Cloud graphics and cloud gamings are the new things, new technologies that bring the server side of the computation powers to your client device. So your viewing experience no longer limited by the client device, the computing device, or the graphics compute powers that you have. The server side can help you. So when we actually look at all these 5 different services and their implementations, very surprisingly, the software building blocks that implement these services are pretty similar. They just consist of about 4 different building blocks: the decode, encode, inference, and the rendering. Decode and encode is a pair of the service that compress the videos and uncompress the videos and deliver those across the network. Inference analyze the content, trying to put more intelligence to this content. And renderings bring high quality and low latency capabilities to your edge devices. So this similarity actually brings a unique opportunities for us to build software stacks around it, to make it simple for the developers to innovate on top of the software stacks that we build. So you focus on innovate on the platforms, but not the low-level details of how to make it happen, right? So more specifically, we are talking about different software building blocks around these 4 different building blocks. So here, there's no reinventing the wheel here. We just simply bring the software ingredients from different places together and make sure that they work seamlessly. Some of these ingredients from Intel, over the years, Intel contributed a lot of different optimized components to the community. And some of them are from third-party companies, and some of them are from open source communities. So specifically, let's look at the decode. There's a SVT AV1 decoders contributed from Netflix. There's a libx264, x265, industry well-known decoders and encoders. There's this OpenVINO toolkit that is a toolkit to accelerate neural network computing. And then Intel rendering frameworks bring the rendering technologies, ray tracing algorithms, etc. to your device. And SVT is a highly optimized codec that Intel contributes to the open source communities. And so we have HEVC acceleration encoder, AV1 encoder, VP9 encoders, and AVC encoders in development. And all of these things are distributed to the open source communities and are open sourced. In order to simplify programming, so we basically put all of these components under the industry standard frameworks like ffmpeg and GStreamers. You don't need to actually write to the low-level details of these software components. You can simply use the ffmpeg and GStreamer command lines. Most of the times you can use these command lines to do the work. That doesn't mean that you cannot write your C programs. For advanced development, you do want to write to the low-level components or write to ffmpeg and GStreamer C-level libraries. But for a lot of developers, simply get the job done and using the ffmpeg shell commands are good enough. And they actually provide sufficient functionalities for to implement the 5 services as we talk about. So on top of the ffmpeg and GStreamers, we also provide the reference implementations, simply to show you how to get things done. So if you're not familiar with certain areas, these applications will give you, these samples will give you a good reference on how to get things done. But if you're an expert in these areas, this just gives you a reconfirmation that we have well thought out of these things and tested for you. So you don't have to go through these things again. You can really focus on, innovate on top of the platform that we provide. So all of these projects are open sourced under github.com/openvisualcloud. So you can see there are individual projects, SVT, AV1, HEVC, VP9. There is the Docker files for setup and installation scripts, and there are samples. Currently we released 2 samples. One is called transcoding sample, the other is called add insertion, where we will be adding more and more samples over the time. So for those of you that build any software stacks, building software stacks is never an easy task. As you add more and more software ingredients into it, there's dependencies among the versions, among the software components, and their dependencies. And there are secret sources that certain things has to be installed at certain places. So if you don't know all of those things, it will be really a struggle. However, building Open Visual Cloud software stack is really easy. We basically sort everything into a table. So you just look at this table and see what use cases you are doing, whether it's media, analytics, or graphics. And then you look at what ingredients are in there, whether you are an ffmpeg developer or a GStreamer developers or Nginx developers. And what platforms and what OS you use, and simply do a selection, and then follow the build command on the left side. So we put all these setup scripts in the Docker file, mechanisms. So if it happens that your projects use Docker files, these are the exact same instructions you use to build the image, and then you can do things on top of it. However, you are not really limited to Docker files. If you don't use Docker files in your projects, the setup instructions in the Docker files still can help you, right? They lay out the exact configurations and the build instructions, so you can follow them in your projects to build your customized software stack. Now, after you develop your applications and you start the deployment, Open Visual Cloud is part of the Intel Select solutions to provide the vertical software stacks. So Intel Select solution, coincidentally, just the previous presentations is all about the combination of the software and the hardware components together to give you the whole solution. And here, this presentation is really about the software aspect of it. Take a step back. If you just look at all the network software stacks, Open Visual Cloud is also part of the network platform that Intel works on to bring you all the software, optimized software components for the network, optimize the network traffics, and Open Visual Cloud is the vertical application stack. Okay, there's enough talk about the introductions. I'd like you to follow along and get started with the labs. So Deval will distribute some papers. You should have 2 papers, right? 2 pieces of papers. One is the login instructions to our VMs. We prepared the VMs for you so you can actually try out some of the lab, some of the features that we developed.
Whoever wants to follow along
Yeah, please raise your hand if you want to follow along.
have a system.
And also, as you go through the exercises, here I put a GitHub link where all the instructions are in there, same as the things on the paper, so you can simply cut and paste if you don't want to type it in. So as part of the lab preparations, we compiled everything into a Docker image called Open Visual Cloud / Xeon / CentOS 76 / media / dash ffmpeg. So the very first step is to run this Docker command to go into the shell environment inside the Docker. Inside that Docker, we have the ffmpeg environment configured, and they are optimized for performance on this particular platform. So the next few commands, cd is to go to your home directory and copy one of the media files over. So this is the preparation stage. Let me know if you have difficulty logging on to those VMs. One of my colleagues will help you to go through the process. Yeah, you need first to log on to the guest network, and then I don't know if you have a SSH client to SSH to one of the jump hosts. If you don't, maybe you can download a PuTTY for Windows, or I don't know which is the equivalent for Mac. SSH, yes. Thank you. Has anyone completed the lab preparation steps? Not yet, okay. Yes. Oh. Can you just log on to the machine? Sure. Anyone has difficulty log on to those VMs? Okay, so you're well into the lab preparation steps.
sure you have a space. Yeah, you could do either. You could do either.
Sorry about that.
Darker role.
Yes, I will do that.
Everybody can see.
Okay.
It's easier than.
Some people have difficulty running the Docker commands. This is because some of the VMs are missing a setup instruction. So the ffmpeg Docker image is not loaded into the Docker engine. So the very first command lines, I type it here. If you run into issues, try the first command on the screen.
This command, see.
Yes, why you?
ffmpeg dash. Yeah, sorry.
Good.
Sorry about that.
That's a command?
Yeah.
Okay, great. Yeah, I often use autocomplete, so.
So far, so good.
Feel free to use the GitHub link because on printouts you cannot make sense of where is space and where is not. So if you can use the GitHub, that'd be more easy.
Yeah, these commands are pretty long, so if you don't want to type it in, just go to the GitHub link and you can copy and paste. Anyone finished the lab preparation? Thank you.
Anyone need help with loading the image and getting into the Docker?
On this screens, at the last command, there is a dot. So don't forget to type the dot. Okay, let me inch it a little bit so people can follow along. So exercise 1, we're getting into exercise 1. Exercise 1 is really about trying some of the ffmpeg commands. ffmpeg is a utility a set of applications that for all kinds of media processings. You can use ffmpeg for encode, decode, resizing, all sorts of pre-processing or post-processing operations. You can even draw text on top of the video, etc. So ffprop is a utility that examines the streams and tell you the information about what is in that streams. So if you run that command, ffmpeg prop, on the media file called travel6.mp4, you can see the one on the screen here. It will show you that this is a MPEG-4 AVC encoded bitstream. And these are the parameters of this bitstream. So the very first command basically tells you what's in this travel6.mp4 video file. So we can, let's just think of it as an original content. And then the second command basically decode this MP4 file into raw bitstream, raw frames. So you use ffmpeg decoders to decode this into raw frames. We do this because we actually run some of the SVT applications, and these applications need raw video frames. If you stay inside the ffmpeg, you don't have to use this command. You don't need to decode it into raw frames. ffmpeg take care of that. But this basically prepares the steps for exercise 2. Yes. Yes. Okay, again, the first command basically examines the video files and print out what's in that video files, what are the parameters of this bitstream. And the second command doing a decode of the bitstreams and save the raw frames, video frames, into the file called travel6.yuv. Yes. Correct. YUV420. That's correct. So we're writing the raw video frames to a file on the disk. Who is the champion of exercise 1? Do we have anyone? You again. Good. So this exercise basically shows you some of the ffmpeg basics, how to do a decode using ffmpeg commands. And you can see that with the Open Visual Cloud, we basically compiled everything into that Docker layer. The ffmpeg is fully configured. You don't have to worry about configuring different parts into ffmpeg. Everything is included in there for your media application development. Excuse me?
And IVF formats?
So IVF, oh, you are already advanced to the next exercise. IVF is a raw elementary stream format, and MP4 is the containers around these video files. Correct. As long as you have the right codec compiled into the application. It's not that much difference because it's just a header, a few headers around the whole bitstream. The majority of the size is the bitstream itself. Yeah. Yes.
Why is the coded height different from the standard code?
So the coded height has to be a multiple of 16 usually. The actual height is can be anything.
And then the B frame, is that simply time coding?
B frame is a predictive coding of the previous frame and the future frames. Okay, since some of you have already advanced to the second exercise, I'm going to explain what the second exercise is. So the second exercise is doing encoding with our Intel SVT encoder, HEVC encoder. You can actually do both exercises. The first one, small exercise, is to use the SVT application, a simple sample app, to encode the video into the elementary streams, treble6_hevc.ivf. And then the second command, ffprop, is the one that actually examines the streams to see what's in there. So you will see something similar, very similar to what's shown on the screen. You can do something similar using ffmpeg directly. So you can use the first command, ffmpeg-i treble6.mp4, etc., to encode videos to HEVC format. And the second command used to probe the video again, so you can see what's got encoded. So compare the SVT applications and the ffmpeg, you can see that the SVT application is a lot more simplified. It actually needs to take the YUV files as input, while with ffmpeg, you can take the MP4 files, the compressed MP4 files. ffmpeg will automatically decode it for you and then encode it to a different format. So that's a transcoding operation. Decode plus encode. At the end, you will see something like the screenshot over here. The bitstreams will contain HEVC encoded content. Yes, that's correct. I'm sorry? Minus B.
1080? Minus H, 1080.
I forgot. Why don't you type this app without any commands? It will show you the help. Let me do that. Actually, can anyone do that? I don't have the environment here. So -b probably is some kind of rate control. It's a flag of some kind of rate control. Simply type the app without any commands. It will show you the help message. Just do a dash help or dash help. It will show you the help commands, the help message. Say?
Is that the one that's highlighted? Yeah, it must be some type of format.
Right. Yeah, the type of the. For those of you who finished the HEVC encoding, so let's advance to AV1 encoding. You can see that AV1 encoding is just to change a few words. It's as equal, if you have finished HEVC, AV1 encoding is just a few words change. AV1 is really, really popular these days. When we first post SVT AV1 onto GitHub, is it within a half a day, we got a 500,000 tweets about this activity. And a lot of people, a lot of communities actually join in to help us to develop SVT AV1. Again, you can encode AV1 using the SVT app, or you can do it using ffmpeg commands. So if you use the SVT AV1 app, the very first command basically do the encode using the raw YUV file as the input and output to an IVF file. And the second command, ffprod, basically examines the streams to see what's in there. You will get something similar to the one on the screenshot on the right. Similarly, you can do this with ffmpeg. You don't need the YUV file anymore. You can just simply, you don't need to specify width and height. You can simply give it a MP4 file that has all the information encoded in there.
We had a question in the audience recently. Could you give us a little background on SVT? What is it?
Oh, SVT is a scalable video coding technology that is contributed by Intel to the open source community. It's a it's an encoder, and it is highly optimized for the Xeon platforms. So the goodness about SVT is during encode, it actually parallelizes all the internal encode mechanisms so that you can actually fully utilize the 36 to 72 cores on the Xeon processors. If you use the traditional open source the encoders, you will not be able to utilize that many cores. So Xeon processors has a lot of different cores. Only the SVT currently can fully utilize these cores for encoding, during encoding. Yes. The logical cores, yeah. No, it's not a part of the standard distribution, but there is a repo here I mentioned. So under github.com/openvisualcloud, SVT encoder is there. That's source code, yes. Yes, you need to compile it. High bar to the entries, but not with OpenVisual Cloud. So here, so we give you 7 build scripts. 7 scripts, 7 commands to build everything. Hopefully that's a low enough bar. Yeah, to build OpenVisual Cloud, you basically need these 7 commands and take a break with a cup of coffee. That's it. Okay, go back to the exercise. How many of you have completed? Great. I see a lot of hands. Let's probably wait for 1 or 2 minutes more, and then we'll go on to the next some slides to summarize this lab. Okay, let's try to gather together now. Trying to see, so first of all, let's review some of the things that we talked about before. So there's 5 different services we defined in the OpenVisual Cloud or the experience. If anyone can help me with these 5 different services. That's great. That's great. Yes. But those are not the 5 different services. Those are the 4 different building blocks. That's great. Yes. Immersive media. Let me show you the things. So first of all, it's the traditional media creation, processing, and the deliveries. And media analytics add more intelligence to the content. Immersive medias add more dimensions to the video content. Cloud gamings and the cloud graphics bring the server powers to your client devices. These are different services that we talk about in the Open Visual Cloud. It's a little bit cheating here because you already answered the question. The 4 different building blocks, software building blocks, are the decode, encode, inference, and the renderings. We build the software stacks around these building blocks. Yes? Inference is using the neural networks to figure out what is in the content that you delivered to the people, and then you can tailor, use that information to tailor the video, the content, and personalize the content. The third question, so what are the frameworks that we support at a high level? The one that you just used. Okay, there's a few of them, but we'll start with the easy one, which is ffmpeg, GStreamers, TensorFlows. These are all industry standard frameworks, right? We just bring these frameworks to you. You can use either one of them. And by the exercises, you can see that you can easily achieve the media operations without even code a line of code. You simply type the commands, right? Using the shell scripts to achieve these features. TensorFlow is a neural network training framework initially created by Google. Because these are the very popular frameworks, we want to adopt these industry de facto standards. Yes?
TensorFlow has depending on what the content is, we have a tab alongside.
Right. I'm sorry?
TensorFlow, when you use,
Yeah.
based on the data,
Yes.
all the video streams that you have to analyze,
Yes.
it could be wrong minima or maxima that you come to and get trapped, that you
Correct.
pass over.
Right.
How do you manage to identify such situations? Then use TensorFlow.
Oh, okay, yeah. Yes, yes. So what you are talking about is really the how to do algorithm development using TensorFlows. Here, we are not getting into how the algorithm is developed. We simply provide the framework for you so you can actually do your algorithm development and do your algorithm application deployment, right? We are not getting into the research areas and how to train the best neural network. Yeah. Yes. We have some of the sample code in the OpenVINO, the OpenVINO SDK toolkit. Here, we mostly focus on how to run the models. Right, you have already trained the models. You give enough data to train the models. We will show you how to run the models efficiently on the Intel platforms. Okay. Let me talk a little bit about some of the reference samples that we provide under Open Visual Cloud. Yes? Yeah.
Initially, we had an MP4 file, which is around 6.3 megabytes. And then we converted that into .uuv file.
YUV file, yes.
YUV file, which is like 450 megabytes.
Yes.
And then we generated a .ivf file, and
Right.
then from that we generated a .mp4 using like AV1 MP4 file.
Correct.
So that AV1.mp4 file is the final file that we will be using for rendering. Right?
Correct.
So the intermediary .ivf and .uuv, we don't need them, right? After
Yeah, we don't need those. IVF is elementary bit streams. We usually don't use it for any of the work. We need to wrap it around into a container before you deliver it.
So the key advantage is from 6.3 megabytes to 2 megabytes is what it has actually reduced the size. That's the main thing. Right?
Correct. The reason that we have to compress it is because we need to deliver it over the network. So we want to compress the size. Okay. So let me talk about some of the Open Visual Cloud samples. So the very first one is the CDN One to End Transcoding. So this sample demonstrates different ways that you can use to stream content using the ffmpeg commands to stream the content over the internet. So the very first stage, you stream the original content from the streaming server to the transcoding server using RTMP protocol. So you basically push the content over the internet to the transcoding server. Then inside the transcoding server, you use again another ffmpeg command to transcode this content to different resolutions and different bit rates, so that you can adapt this to the network conditions. And then you use the RTMP push again to send it to the CDN servers to cache it to the edge. On the CDN, you use the Nginx software stack to cache the result and make it available to the end user, the browsers to watch the video. So you can see that there's 3 different pipelines here. It's called a ffmpeg pipeline. Another ffmpeg pipelines, the first ffmpeg pipelines to push the videos from one server to the other server, and the second pipelines to do the transcoding, and then the CDN side, there's the Nginx pipelines to cache the content and make it available to the edge devices. So I show here some of the pipelines here. This is the transcoding pipeline. So if you just simply type these commands into the shell scripts, it will transcode the content from one format to multiple outputs. That's why the reason we call it one to n is because we take one input and we transcode to n number of outputs simultaneously. Correct, yeah. You can also encrypt the content along the way if you want. Yes. Yes. This is usually based on how the network is configured. So you have presets to say that I want to transcode the content to 640p, 720p, 1080p, etc. So this is pre-configured. Yes. Yes.
One is with the HEVC, the second one is with the AV1. Is it not like?
I cannot hear your question.
I see that we have used encoding one with the HEVC, SVT-HEVC. The second one is with the SVT-AV1.
AV1, yes.
And we only got one file finally generated, which is one MP4 file. So what is the purpose in, okay.
There's 2 files generated. One is encoded with HEVC, the other one is encoded with AV1.
Okay. And what's the difference, sorry?
So these are just different codecs. HEVC is an MPEG standards, and AV1 is a free codec that is Google helped standardized.
Thank you.
Yes. Yeah. So basically, the CDN manager will handle the workload to figure out which. So if certain workloads comes into the transcoding server, someone has to schedule the work, right? Yes, we have multiple. We'll put the things into the queue, which is called a Kafka queue, and then the workers basically take the workload from the Kafka queue and start to transcode it. And when this is finished, it will start to take next workload and transcode it, something like that. This is VLD, yes. Yeah. Any other questions on this slide? This sample just show you some of the scenarios. It's actually a mixed scenarios of multiple things together, just to show you how to use the pipelines and how to use these ffmpeg commands for different purposes. Next sample, we are talking about another use case where we use analytics to analyze the video content during playback. And then we figure out, okay, what's in that content? And then during an ad break, we will try to replace these ads with something more relevant to the things inside that content. So for example, if you see a bike, let's say that you see a chair in the video. The subsequent ads will be replaced with some furniture ads, something similar. So you can imagine that the ads will be more relevant to what you see in the videos. That will not be so abrupt, right? If you watch a hollow videos, right? You don't want to suddenly see the ads that is really happy and all those things, right? So this basically allows you to, allow us to analyze the content and make the ads more relevant to you. So. Yes. Uh-huh. Right. Right. They don't communicate directly. Yes, yes. So the ad decision service does need to talk to the ads content service to get all the list of the ads, but in this particular implementations, they don't really need to know each other. Yeah. That's true. That's true. Yeah, that's inaccurate in the diagram here. Yes, I agree. Okay. Thank you. Thank you for pointing out the inaccuracy here. There's a dash lines over to the top. Yeah. So underneath, so it's basically a on-demand analytics pipelines as well as a on-demand ad transcoding pipelines. So we will demonstrate 3 different pipelines. The first 2 pipelines one is based on ffmpeg, the other one is based on GStreamer. So you can use either one of them. It just depends on your preference. So you can use ffmpeg to analyze the content, and then use that to influence the decision making and replace the ads with something more relevant. The ad transcoding pipeline transcode the ads from the quality of the high-end ads to something that matches with the video. So you don't you don't see something like, for example, if you see a low resolution video, you don't suddenly see a high resolution ads, or vice versa. So something like that. This is to make the whole experience more smooth for the end users. So let's get to more of the samples of the command lines. Basically, these command lines are a little bit more complicated than what you use in the lab because we have to enter the models, the input files, etc. But the spirit is the same, right? You can use command lines to do inference. Everything will be, you use these command lines to enter the models, the input files, the output locations, and then the pipeline will execute and give you the data back. Yes. They are currently part of the ffmpeg. Yeah. So if you go to the ffmpeg repositories, you will not see those things. These are the new filters that we create, and we are in the submission process trying to stream it to the mainline of ffmpeg. Yes, yes. But if you go to our Open Visual Cloud repositories, you will get everything. We're in the process of upstreaming these things to the open source community. So the XML files is the model.
So how do you build the models? Like, for example, tomorrow,
So you use the TensorFlow's Caffe frameworks to build the model. You need to train the models. And these XML files are just a representation of the model.
Okay, thanks.
The data set. We are not really getting to the stage of how to do training. So we assume that you have already done the trainings. We will help you to execute these models and make use of these models.
Hi.
Yes.
Question. On the XML file, and I believe that's the open model. OpenVINO model. So does it mean that so these have to be trained for the 32, like FP32, FP16, and etc. So these have to be matched to the platform-specific the .xml and .bin on OpenVINO.
Yes and no. You don't have to be exact match in order to run it. Inside the OpenVINO toolkit, there is a tool called the model optimizer. So you can run through the model optimizers, and the model optimizers will automatically optimize your models to the platform.
Okay, I'll follow up.
Okay.
I believe I thought. I was that one has to actually do the, for example, there's like even just the type of processors, not just the precision. So
Correct.
If
they don't match, you run it through the model optimizer.
Yeah, but previously, just now, you just said it will the optimizer will actually do it automatically, and is my understanding that it is not automatic. I'll follow up.
Okay, thank you. Yeah, we'll follow up on that. So this is the same equivalent pipelines that you can do with the GStreamer. So this gives you an example of some sense of how the GStreamer work. So again, similar situation here. You can get these filters, GStreamer filters, under our repository. It's all open sourced. But if you go to the GStreamer main repositories, you want to see these plugins. We are still in the process of upstream it to the GStreamer community. Finally, a call for actions, right? To try Open Visual Cloud at github.com/openvisualcloud. So be innovators in the devmesh.intel.coms, and let's build these things together. If you're interested, we can build these things together. We are following the open source development model, and any contributions, feedbacks, and bug submissions are welcome, and code contributions are really, really welcome. We really want to make it a community project, not just Intel contributing to this, but all the third-party contributions and all the things. Let's build it as a community project. That's the call for actions for this lab. And finally, I know you are really, really busy and got a lot of things to do, but if I can ask you to remember one thing of these presentations, remember this Open Visual Cloud. Open Visual Cloud, a compound word, and then do a Google search, you will find us. Thank you.